Okay, so explain using dot and cross diagrams the formation of ionic compounds by electron transfer, limited to combinations of 1, 2, 3, and 5, 6, and 7. So, combination, the most simplest is a combination of 1 and 7. Okay, so let's look at that one initially, and it's the most common example looked at, which is the example of sodium and chlorine to make sodium chloride. So sodium has an electron arrangement of 281, and chlorine has an electron arrangement of 287. So an electron transfer occurs where sodium will transfer one of its electrons onto chlorine. So this goes from here onto there, and you end up with Na plus and Cl minus. Okay, so that's your most simplest example. So the next example is magnesium fluoride. So we're only looking at outer shell electrons now because you get the idea. So magnesium has an electron arrangement of 2, 8, 2, and fluorine has an electron arrangement of 2, 7. So I've only put outer shell electrons so you can see what's going on. So magnesium is going to lose 2 electrons and fluorine is going to gain 1. So this electron here, is going to go on to this fluorine. Okay, but we also have another electron that's going to be lost from the magnesium. So this can also satisfy another fluorine. So this electron here is going to be transferred on here to this fluorine. So we'll end up with Mg 2 plus ions and 2 F minus ions. So overall the formula of the compound is MgF2 because magnesium keeps 2 fluorines happy. So looking at another example, which is aluminium oxide. So aluminium is an electron arrangement of 283 and oxygen has an electron arrangement of 2, 6. So you can see I've only done the outer shell electrons on here. So aluminium is going to lose 3 electrons. So aluminium is going to transfer this one to oxygen here and this one to oxygen here. So we've kept one oxygen happy, but we've also got another electron going on. So what happens exactly? Okay, so what happens, I've drawn the oxygens a little bit smaller just so you can see what's going on. I can keep it all on the one screen. So this aluminium will donate this electron to another oxygen. It's going to keep that one happy there. So the next aluminium will donate this electron to this oxygen here. So there's 2 oxygens now kept happy. And the final 2 will go on to this third oxygen here. So we have now had electron transfer between a group 3 metal and a group 6 non-metal. So aluminium made a 3 plus ion and oxygen made an O2 minus ion, and we have then formed a compound which contains 2 aluminium atoms and 3 oxygen atoms, a ratio of 2 aluminium atoms and 3 oxygen atoms.